Hey everyone, in this video we are going to talk about domain and range of radical functions. We are working on IXL FF.2. We are going to decide what the domain and or range of a given radical function by looking at its graph. So overall, let's talk about a little bit about how the graph of a radical function looks like. So thinking about radicals are like square roots. Those are the radicals. So here are some examples. Radical 3, radical 10, or radical 0 is the smallest that I can come up with, or 1 million, or 1,000. I don't want to put 1 million in there. Okay, so this one here is going to be somewhere in between 1 and 2. The number is going to be in between 1 and 2. This right here is going to be in between 3 and 4, pretty close to 3. This one here equals to 0, and that one here is, I don't know what that one is. Let's just make this 1,000, 10,000, and then it would be equal to 100. So, as you see, these are not getting any less than 0. The smallest radical value you can come up with is equal to 0. And it can go on forever. So look at this graph. The smallest value that you can get on the y-axis is 0, and it increases like this. It first increases a little, and then it gets slower because when you plug in 0, it is 0. When you plug in 1, the value equals to 1. When you plug in 4, the value is equal to 2. If you plug in 9, it should be 3. So as you see, we are over here. When we jump from 0 to 1, it's just 1 unit. The answer, the value goes from 0 to 1. It's just for 1 increase, the answer changes by 1 as well. So for when we increase the x by 3, the y changes by 1 only. From 1 to 2, the difference is 1. So when we had initially, we had 1 difference for x and y, 1 difference for x and y, and then for the second step, when the y changes by 1. And then for the third step, if we increase the x by 5, 4 plus 5 equals to 9, the change in y is still just 1. So the increase is getting smaller and smaller. That's how square roots or radicals behave. So the function, the graph is always going to look like this. So the starting point can change, but that's how it's going to look like. Now, after reviewing how the graph of its radical look like, let's talk about what we are going to do in this assignment. We are going to see what x value can our function get and what y value can that function get, okay? That's what this assignment is about. So for the domain, we are talking about x values that we can plug in for this function, for this radical graph, the blue one. So remember, domain is all about the x values. Don't think about the y-axis, the up and down movement. Just focus on side to side. So here is the x-axis. Now see if there is anything that stops your graph to go any further to the left or right. Now let's talk about this arrow. Okay, what does that mean? Arrow indicates that the graph goes on forever, right? I think you all know that. So when you see an arrow on a coordinate plane, that means it goes on forever that way. So this graph goes on forever to the right side. So the domain of this function is we increase the x values from 2 to 4 to 6 to 8 to 10 to 100, 1000. It goes on forever. So on the right side, we have positive infinity. And we are talking about the x values. I want to see how this is. Okay, let's just use this notation first. So x goes to infinity on one side. For the positive numbers, it goes on forever. Then we will try to match up with our answers. On the left side, does this go on forever? The blue, do you see an arrow on the left side? I don't see an arrow. I see a point. Over here, I just see a point that's stopping the graph from going any further left. So the graph is not going to go any further than 0, but can it be equal to 0? Since the point is filled in, it can be equal to 0. If it was like this, then that would mean whatever this number is, if that number is 1, let's say on the coordinate plane, so then we would say that the x value is going to be greater than 1. That's how we would write the the interval of the domain. It's not equal to 1 because the circle is not filled in. But in our case over here, let's just get rid of this. In our case over here, the 0 is included. The blue dot is filled in. So we will say that x starts from 0 and then it goes on forever, right? So it's in between 0 and positive infinity. That's one way of writing the domain, not this. I made a mistake. Here's the mistake. Infinity, you cannot make the number equal to infinity because infinity is a concept. It's not a set number. It just means it goes on, it continues. But we know that it could be equal to 0, right? If x could be equal to 0, you need a bracket. Parentheses tells you that it cannot be equal to that point. If you have a bracket, it could be equal. But I don't think, looking at the first option I see down here, I don't think that is the notation that I can use for IXL. Let's just write a set. So the domain values are going to consist of all of the x values such that x is going to be greater than or equal to 0, and it goes on forever. That's the same thing. That's what I'm looking for. So scrolling down, let's see if that's an option. It should be an option. Okay, I think it's the second one. Yes, the second one here is what I need. X values should be greater than or equal to 0. And if you just look at the blue graph, it starts from 0 and it goes on forever because of the arrow. It starts from 0, it should be equal, and it goes on forever. Okay, let's jump a level and see what other questions we have. What is this? Let's see. Let me pause the video. Okay, now here's the second question. It says, what is the range of this function? The first one was about the domain. It was about the x values, the horizontal axis. This one is about the range. It is about the y values, up and down movement. So let me get this out of the way. Okay, this is about the range. It's about the y values. Up and down movement. Like, see if there's anything that limits your graph to up or down. So this right here, I like to deal with the arrows first. So I'm looking at this axis, right? Just focus on up and down movement. So this arrow is on the upper right corner. It goes up and right on forever. So it goes up forever, it goes right forever. So all these positive numbers are going to be part of my range because of this arrow. It goes up and it goes right. It goes in two directions. But what about the left and bottom? Is there an arrow on the other tip of this graph? There is this point that stops at 0 right here. It does not go any further down to -1, -2. I don't see any graph. I don't see any green graph in there. No curve is in this area. Nothing at all. So which is why those negative numbers are not part of my range. My range starts from 0 and then it goes up. It'll go up slowly. It's going to get slower and slower every time when I increase the number that I plug in, but it goes on forever. Whether it goes quickly or slowly, it goes on forever, up and right. So let's just set it up. Let's write our set. range is all about the y values, so all of the y values such that, so that straight vertical line means such that the y values are going to be, the smallest y is 0. It's an included circle, it's filled in, so y could be equal to 0 and it could be greater than 0. So that's what I'm looking for in the options. So y is greater than or equal to 0 is the last one. So moving on to the next one, let's skip a level. This one here is about the domain. We are talking about the x values. If you looking at the, when you look at the options, if you see anything about y, just ignore it. But there's nothing about the y. So this right here is all of the x values that the function can get. We have an orange function. It starts from 1 and it goes to the left. So 2, there's no orange graph corresponding to 2, 4, 6, 8, and 10 on the x-axis. So here, this right here, this level is where my graph starts from, right? It stops at 1. 1 is included for the x, so it's all of the x values such that x is equal to 1. That's one thing. Is it going to get smaller than 1 or greater than 1? Look at the orange curve. Is it going to correspond to negative numbers or positive numbers? Like when we go left, with this arrow on the left, it goes on forever to the left and up. So all these negative numbers, as you see, that are less than 1, including the 0, is going to be part of the domain. All of those numbers, 0, negative 1, negative 10, negative 100. So x values should be less than 1, but also it could be equal. That orange point was filled in. Remember, since it was filled in at 1, we include that 1 as well. So x is less than or equal to 1 should be the domain. 1 is my point, starting point, and then it's getting smaller. Okay, let's do this one too. The range is about up and down movement. Let me see, I have all 4 options on the screen. Okay, range is about the y, up and down. So this is what you're looking at, okay? Up and down movement. See if the graph is kind of got stuck in between 2 lines. So there's this point, that's my starting point. It starts from negative 5. Is it getting smaller or greater? So it's going down to negative 8, negative 10. So my y values, because I'm dealing with range, the y is going to be less than or equal. Is it equal? Yeah. Since it is included, the point is filled in, less than or equal to negative 5. So y is less than or equal to negative 5 is this right here. That would be the answer. So moving on to the next level, probably they're going to ask about both of them, like what's the range and domain. I want to see if there's such a question. And let's do this one as a challenging question. What are the domain and range of this function? First, let's focus on the domain. The domain is going to have the x values, range. Okay, we cannot eliminate any of the answers because they are including the correct variables for domain and range. Okay, so that's my starting point. Domain is about the x. It starts from that point, right? And on the graph on the x-axis, it corresponds to negative 3. So for x, I need to see that negative 3. So let's just see which ones we can eliminate. We cannot eliminate any of them because they all have negative 3. Great. Okay. Next, decide on the horizontal axis, on the x-axis, are the graph increasing or decreasing? Is it going to start dealing with bigger or smaller numbers as we do this? Starting from the point when we move, when we follow the graph, look at the x values. Are they increasing or decreasing as we do this? I think they're increasing. Because when I am at that point, x value is negative 3. When I go over here, it's -2. If I'm on this point on the graph, on the curve, it's at 0. Right here, it is at 3. Right here, it is at 6 and 8 and 10, and then it's increasing, and it will go on forever. So the x values are going to start from -3. It can be equal to -3, and then it'll increase. So for domain, it's all of the x values such that x is greater than or equal to -3. So that's what I need. This is less than or equal to -3, greater than or equal to, that could be the answer. This could be the answer. This cannot be the answer. So my options are limited to these two options right now. Am I going to say y is greater than 7 or less than 7? That's the difference between the two options that I have left with. Now let's decide which one is true. Looking at the y, the range, the graph starts from this point, right? And I'm dealing with the y values. The y value at that point is 7. They both have 7. But is it going to get bigger or smaller as I move on the purple graph, purple curve? So right here, I'm going down on the y-axis. This point, for example, its y value is 4. The y value of this point is 2. The y value of this point is 0 right here. The y of this right here is -2. And so on. So it's decreasing. It's going down on the y-axis, so it's getting smaller. So the y values are going to be all of them such that y's are less than or equal to +7. So less than or equal to is this right here. So my answer would be this graph, the third option. So that was all for domain and range of radical functions. They usually start from a point which is included, and then from that point it'll either increase or decrease. Thanks for watching, and let me know if you have any questions. I will see you in another video, guys.